damos inicio entonces al primer módulo del día de hoy llamado Redes y Tecnologías, con la conferencia Fuentes de energía distribuidas a cargo de Navneet Trivedi. Navneet es cofundador de Vrinda Inc., compañía que se ha dedicado a crear estrategias de negocio e implementación, especialmente en el área de nuevas energías y soluciones tecnológicas. Navneet ha trabajado con entidades reguladoras, gobiernos, con entidades de servicios y agencias multilaterales alrededor de 7 países, buscando desarrollar la implementación de poderosos programas de transformación del sector de energía y servicios. Navneet tiene una maestría en energía renovable de Indian Institute of Bombay y es graduado de Ingeniería Eléctrica y Negocios de la Universidad de Columbia en Nueva York. Welcome, Navneet.
Good morning. Buenos dias. That's my Spanish. That's what I learned in last 2 days. Thank you very much for inviting me and giving me this opportunity to talk to you today. And I also want to congratulate you on 20 years of your power markets. And as I have worked in many countries, to have a power market and run it for so long is not easy. So I really congratulate you, each of you, to kind of make it a success, like to run the power markets in Colombia for 20 years. I want to talk today to you some of the debate which we are seeing in United States in terms of when utilities are trying to bring distributed energy resources into the market and what are the challenges. So I have the control in my hand, sorry. So what essentially I want to talk to you today, sorry for the technical. Okay, great, thanks. So I'll talk to you a little bit, like very briefly about what I do now, and then I talk to you about what is changing in the industry, what we are seeing, as I work with many utilities in US as well as in international. We'll try to see, what is changing, what is creating this change, like what are the key disruptors, and we will talk about what are the challenges to the industry with these disruptions. And I'll also share with you some of the debate what is happening in US, like in terms of what US companies, US industry is debating right now to address these challenges. And then I will touch upon a little bit like what Colombia can do in coming years to kind of prepare toward this and why. So I worked for 23 years into the energy and utility industry, as you must have seen. I spent all these years working with electric utilities, and I have been to 7 countries. So I got a privilege of working to see countries right in Asia. I worked in China, I worked in India, and then I worked to North America, and then I worked in Brazil. So I got very good understanding of what's going on actually in developing markets as well as developed markets. And with all that experience of working for 23 years, I started actually on my own to help in US, especially utilities, to kind of figure out the new business models which are coming up with the integration of renewable energy. And when I say renewable energy, I want to make it clear, I will use the term distributed energy resources, which includes storage, demand response, energy efficiency, solar, and all of these things are collectively called distributed energy resources. So essentially what I do is that I work with solution providers and utilities at the intersection to kind of bring the value, because this whole game about the renewables is, do they have value? Which a lot of people, especially in utilities, are skeptical about the value of DERs when they call it. They don't know whether solar is really useful for the grid or it is hurting the grid. Is storage going to play really a big role or not? So, the whole thing comes up to like, what is the value? So that's where I work actually, and these are some of my clients whom I am working with. Among them, I also advise with the New York Governor's Office on the REV program, if you heard of. It's called Reforming Energy Vision for New York State. And New York is one of the early adopters, basically with a bold vision to transform their energy markets to have more distributed energy resources integrated into the grid. Okay. So as I was kind of talking to you, I want to skip this slide, but I have worked in like many countries. I have 23 years of experience going across the world, and I have worked in right from generation to retail. So I have been working in generation. I started career with designing the wind power plants and constructing the wind power plants. Then I went into conventional power plant, like design of thermal and gas power plants. Then I moved into automation. I worked in a SCADA EMS system for quite some time, and then for 10 years I worked with PricewaterhouseCoopers in the management consulting services, and then I was with Accenture for 5 years. So, and as I said, I worked in many countries, so I have got like this view of what the debate is in the industry. So let's see, like what is changing in the industry. So one of the biggest change in the industry right now is central generation. We are moving to distributed generation. As you know, in 2015, 23,000 megawatt of coal plants are retired in United States. And US has reached up to 50% of their installed capacity is retired now for coal plants. And there's a very ambitious plan to phase out coal from the system. And interesting part is no new plants are getting built of large capacity. So we all should wonder why we don't need new energy. And it is true that gas is definitely contributing to some part of new capacity, but most of the capacity is coming from solar, wind, and these new renewable energy sources. So that's like the change happening as far as generation goes. As far as grid goes, we had this legacy grid, and we have a planning process by which we took a long-term plan and we look at the load growth and we project what is going to be the load, and then accordingly we plan for expansion of generation or transmission and to large extent distribution. But in the new paradigm with the smart grid, you can do lot of value out of the existing grid. You can manage the congestion in the network, so you really don't need to expand the grid the way traditionally we used to plan. So that's like what is happening as far as the transmission grids are concerned. The debates are going on that should we move from a centralized planning to decentralized planning for the grid. And on the consumer side, the most interesting is largely customers don't care about electricity. That's the perception, and that's kind of quite true for many customers, because they just get the electricity, they pay for it, and then they are happy and they call the utility only if they lose power. If there's an outage, they will call you. But that is changing. Like, so in US, at least what we are seeing is that consumers are becoming prosumers. And what it means is producers of electricity as well as consumers. And this is giving a new paradigm shift, because now consumers can participate into the whole market. Now, why this change is happening? So one of the thing is, if you look at where the money is going actually in the industry. And as it's very clear, there's a six-fold increase in the investment in the renewable energy and distributed energy resources in last 10 years. So if you look at 2004, and you can see the region, like who used to invest, and like look at 2014, there's a phenomenal, like $318 billion was the investment in 2014 as far as renewable energy goes. And one interesting trend is that look at Asia. Asia is contributing to more than half of that investment. So the people with the most populous countries in the world, like China and India, they are putting the renewable energy. What it means is that it is going to bring down the cost further because now you got the scale of the technology. So one of the question we always had this, that renewable energy is not competitive because they are very costly resources. So that is definitely going to go. And that's not the only thing what is going to happen. It is no longer in the industry about the politics or the policy to promote the renewable energy, which we need to understand. Because a lot of countries and a lot of players, they say that, it's not applicable to us. We have other resources. But look at the cost, and is it going down? This is like a projection from Bloomberg New Energy Finance. You will see that solar is actually coming in the range where it is competitive with other technologies. And look at wind. Wind has already kind of achieved that parity. So when you have a source which is like at par with coal and other technologies, and it's clean, people will obviously opt for that. And there is not only this projection, but there is a fact here. As you know that in US, the latest bids for solar have come up to $50 per megawatt hour and less. I don't know any of you follow, but Austin, Texas, they signed a PPA at 4.5 or 4.6 cents per kilowatt hour, which is, I think, at par with the, coal. So, so as far as solar, the biggest challenge was the cost, which is like now has moved from there. But the story is not ending here. If we think that, okay, a lot of people are saying that, polycrystalline silicon wafer, basically they have a limit. They have efficiency of 22%, 25%. And you cannot go beyond that in terms of having more efficiency. So the cost reduction is not possible, which is true in today's environment because the balance of system costs have gone up as a proportion of the total cost much higher now because solar technology costs are not coming down, substantially. But, the disruption is already happening. I want to point out there is a new material which kind of, it's not that new, but has come. It's called perovskite, and that material gives you same efficiency as silicon today. And it like in the last few years they figured out. And the best part is it operates on two different, spectrum of light. So what it means is that from a solar spectrum, if you have a silicon and a layer of perovskite, you can get double efficiency theoretically. So this is under research, but people are very kind of bullish on that, and US government is putting a lot of money on this research if they can combine. What it means is that if you can get the efficiency of like 40% in solar. So today, we already achieved the economics of solar by 20%, 22% efficiency. If you had 40%, I think we will not be talking about cost of solar in next 5 years. So that's what we are talking about as far as the disruption goes and solar energy, So you will not be surprised if we are talking about 2 or 3 cents per kilowatt hour for solar in next 5 to 7 years. The next biggest disruption, as you know, and like a lot of people are excited, is the storage. And a lot of people didn't think that storage will come so early in the market. We are already talking about very competitive technologies. I work with number of clients in US who are interested in storage. And the reason is that because ever since we started this journey of renewable energy, one of the biggest negative was intermittency, that wind has a fluctuation, solar has a fluctuation, and there is nothing which can counter that thing. Either you have to have a gas turbine, which has to ramp up very fast. But now, like people always kind of dreamed of having something where you can store the energy. And now storage has come and is in a big way. And as you know, there are two things actually on the slide. I don't know you can read it or not, but this is a study done by CESA, which is a California Energy Storage Association. And what they have demonstrated that if you have a storage and you have like, a different capacity of storage, They are saying that if in the grid we have 2,650 megawatt of storage in California system, they can push 11,000 unit starts away. So basically you can do away with storage, like start of the gas turbines. The value of the renewable curtailment, like, so what happens today, because if there is a high availability of solar power or wind power and there is no load, you need to back down the wind turbine. They are saying that by having 2,650 megawatt of storage in the grid, you may be able to avoid 40% of curtailment of the renewable energy. Now that's something which we all were looking for. So if you add storage with the solar or wind, you may get a lot of value from that. And the story is not ending. As you all know, Tesla has announced a gigafactory, which we all hear, and that is still not operational. It is going to come in like around 2017, 2020 time frame. And it is going to bring the cost of storage to $100 per kilowatt hour range. And that is going to make it more competitive. So that's like the other disruption. The third and the most interesting thing is this whole notion of energy efficiency and demand response. And it's been there, like in United States, when the oil crisis happened in 1970s and 80s, they started demand response program. So demand response is not new to the industry. It's been going on. But what has changed now, the way demand response is administered. So earlier, the traditional approach was when you have to have a demand response, like a control switch in your home, and then utility will send a pager signal to control, and they have to own the whole communication network along with that. Now, what happened with the Nest thermostats? If you know the Nest, it is a Wi-Fi enabled thermostat. And it says, it has created a new model called bring your own device. So essentially, anybody can go to a store and buy a thermostat and put in his house. And it just like as you pair your iPhone with your home network, you can pair your thermostat and then start controlling the thing. So what is happening that it has reduced substantial cost for companies to acquire customer, to installation costs and things like that. And that is kind of disrupting how the demand response is looked at now in the residential area. And there is a lot of things. Like if you look at the investment side, in 2012, $360 billion was invested in energy efficiency and demand response in US. So it is, when the investment goes, the money goes behind some technology, you know that this is real. And this is the latest survey, as you cannot read here, but around 38% the utilities in the last survey said that they are administrating the demand response program. And like 17% is done by the third-party aggregators. So right now, if you look at these two numbers, together like 50 to 60% demand response is either provided by third parties or the utilities themselves. So that's like a big third disruptor which is required, because as I was talking to Professor a few minutes ago, means if you want to manage with the solar and embedded distributed generation, you need all of this. You need to have a storage, you need to have control on the load, your load has to be flexible. So what I'm trying to kind of tell you is that these three key disruptions, cost of solar, storage, and energy efficiency and demand response, this can make the game changer kind of disruption in our industry. So what is the debate in US right now? Like what we are debating? Number one is retail competition. So as you know, like when California market issues came around the world, I was in India that time, and like people stopped talking about markets. Having energy market was a bad thing because of California. And in US, like I live in New York, and we have a retail competition, but it's not very successful so far. But what is happening with the new technology disruption, if you want to see, and I have put this slide here, if you combine your solar, your distributed storage, you combine your energy efficient demand response, 40 to 70% of a customer's demand can be met by these three resources. And I don't want you guys to believe in this number. Even if you take half of it, and think of your utility, if 35% of revenue of your utility disappear tomorrow or in like next 5 years, will the utility be viable? That's the question. And this change doesn't require any regulatory approval. Because if I want to put a thermostat in my home and I want to switch off my light, if I want to put a storage battery in my house, nobody can prevent me from doing that. That's not like, by regulation you can say that you cannot have a battery in your house or you cannot be more efficient. So that is like one thing. So it's about retail competition without market changes. The second thing is role of utilities. So though we are like, utilities are worried about revenues and cost of service and return on investment, but the debate is not about that. Debate is about what is the future of utility, really. And why is that? Because cost of service model is getting obsolete, because utilities are not able to recover. As in US, we have seen the demand is stagnant, people are defecting from grid, and you can fight as much you want to kind of charge to other customer, but that doesn't go very well. So as a result, either their revenues are stagnant or they are declining. Natural monopoly is threatened, as I said in the previous example. Anybody can reach to a customer and give him a solution to cut his demand by 10% or generate his own power 20%. So natural monopoly of the utility, where they were the only one who were supplying energy, is threatened now. Retail competition we talked about. Financial stability for many utilities is like basically it's coming about diminishing profit potential and increasing cost of capital. So if your cost of capital is increasing because more and more money going into renewables and they are not getting invested through utility, utility will have a hard time getting cheaper money coming to them for their traditional business. So that's the second thing which is, we are debating, what is the role of utility in the future? And that's where most of the utilities in Colombia also need to think that, because don't see this as is not going to come to you. It is not, it's a matter of time before you will see this thing, because as I said, it is not driven by policy or something, it is driven by economics. So when economics drive things, things come. The third debate in US right now is about the value of these DERs. So we all agree that these distributed energy resources, do they have real value? And how to get the real value and how to calculate the value. So I want to show you something. This is one of the examples from one of the client I'm working with. And what I do is that we calculated for 1 megawatt of different resources. So what are those resources is that a battery, which is behind the meter, which is not recognized by ISO, like the market operator, a battery which is recognized by ISO, a demand response program, an energy efficiency, a gas turbine, a solar, and a solar in both kind of models, behind the meter and ISO. What you see here, you can see the clear value stream. So you have to, if you are trying to kind of adopt renewable energy in your system, or you're trying to buy a demand response, or you want to, promote a battery solution, what you need to do is that you need to first calculate the value. You should be able to tag the value of these resources to the market, or what are your drivers. So these are some of the typical drivers, like in US we consider. So what is the energy value of this resource when it produces? So like, for example, solar, and I'll show you an example. Nowadays, it's a very typical phenomena, interesting happening in California, that price of solar is coming to zero at the time when it is generating the most. So it's a very interesting thing because of the large amount of solar coming in the middle of the day. But then there are like capacity values, there are reserve margin kind of values, which is ancillary services, transmission avoidance, because one of the thing people talk, at least in New York, is they are looking into alternative ways. I don't know, you heard about this project called Brooklyn Queens Demand Management Program. And essentially what they did is, utility came to the regulator saying that I need $1 billion to make a new substation to supply a new load in Brooklyn. And industry said, no, we can do an alternative. And ultimately, they approved a $200 million program of demand management in that area. And essentially, that will mitigate an investment of $1 billion. So these are the kind of thing which is like, driving the value of the, distributed energy resources. The fourth thing is net metering. So as you know, this is very controversial. In many developing countries, net metering is being promoted, like, as a fundamental kind of approach to promoting solar. But it is not a good policy. It is hurting actually. People have realized that net metering is actually more hurting than anything else in the growth of renewable energy, especially solar. And here is what it is. Actually, I have pulled it from a MIT analysis. So what happens that when a customer adopts net metering, and it is a retail customer, he gets paid much more value than a wholesale guy who is connected in the wholesale market to supply, because the wholesale prices are lower than retail prices. That is number one. So, and then the price which a retail customer get paid is compensated with other customers. So the rest of the people are paying to that guy on behalf of everybody else. So net metering per se as a policy is not working. So that is one thing you need to understand, and when you debate your kind of thing, that it may not be necessarily the best thing. You have to calculate what is the value of the solar or any resources at that point, and that's kind of you need to devise a mechanism to kind of compensate to these resources. Don't make such policies which kind of going to hurt you. And I'm not surprised because I'm an electrical engineer. When I was starting, I was always wondered about this net metering policy. But now, even at a penetration level which is very low, US has like what, less than 1 or 2% of renewable energy or solar. We are talking about the net metering is not working. So we need to have a policy which can work for a long-term sustainability of the market. And then the question comes of the energy storage. So this is, I think, this is called California duck curve, right? It looks like a duck. And as there's a projection here in the CESA study, which is California Energy Storage Association, that as you generate more and more solar, you will have more and more dip into the between 9 a.m. and 6 p.m., right? So this creates two problems. One is, if you look at the price, in this period, it's going to go down. As the more megawatt goes here, in this curve, I'm not showing the pricing, but the price also goes like this, the price of power. So one problem comes is that if the price of power is zero, then nobody can build a solar plant also. Neither they can build a gas plant. Nobody can build anything because the price of power is zero at that time. So that is one power problem in terms of investment coming into developing the resources. The second problem is, this ramp, and who are from system operation, they know what it means. So at around 6 p.m., like 5 to 6 p.m., they are getting a huge ramp of, close to 10 to 12, 15,000 megawatt, and suddenly they need to bring in all gas turbines. Now, if in the current operating characteristic, it is difficult for you to shut down the gas turbine in the daytime and then start suddenly in the evening, because all units may not be able to perform unless you are operating strictly on open cycle. So the value, like, the debate is like what the role storage can play. And as you can see, if you add more and more storage, basically you can bring this peak down and you can, reduce this valley when the power prices are low. So you can enhance the value of the overall, renewable package. So that's like, what is the role of the storage in the system? That is the other debate. And you need to kind of look in your system and see what, when you are trying to do with the new renewable energy sources, what storage can play the role. So I have laid out like what the debate is, and I wanted to tell you like a little bit about what is the model, like what approaches US utilities are taking. So there are basically 4 things in US people are debating right now. What should be the operating model for the utilities? What should be the market model? What should be the business model? Is how we are going to pay for these things? And what is the technology model? So I want to kind of touch upon each of them and show you. So first, actually, in the operating model, and that's where the New York vision, I don't know, you heard of this New York REV program, which is called Reforming Energy Vision. And again, I was talking some time back, like, I don't agree with the implementation approach. I want to make it very clear. I wrote about it. But I agree with the vision. And the vision of REV, I don't know, you can read out here, it says that we should be able to extract value from distributed energy resources. So what it means is that if you look at, this is our traditional grid, where you have coal and nuclear plant, and then you're a transmission line and a customer which is like not happy, or at most I would say indifferent. What New York REV is proposing is that, this traditional model remains on the side, and they can still have customers who are connected and they don't care. But then this is creating a new model of distribution service provider. And essentially what it is saying is that if customers want choice in terms of able to buy demand response, energy efficiency, solar or battery, utility should be able to facilitate that thing. Because a lot of information today is with utility in terms of customer and their behavior. And for a third party, like a technology provider, it's very hard to reach out to the customer to kind of supply any of those things. So New York Rev is proposing to create a distribution service provider. The debate is like who should be the DSP. And in the current setting, they said utility should be DSP. But the problem with that is they said that utilities will not be allowed to own any renewable energy, any demand response or energy efficiency unless there's like a last resort, like nobody else is doing, which is creating a lot of problem for utilities because they are seeing that as a threat to their business model. And that's where the debate is right now in US. But the essential debate is about the operating model, like how we are going to operate. And there will be like, better solution, but there is definitely that need for sharing the information. There is a need for providing access to the customer. And also there's a need to provide access of these resources into the market. You should be able to take them to the market, then only you will know what is the real price. So if I have, like say, 10 kilowatt of storage and solar in my house, what is the value of that? The value is what is the value you can get in the market at that hour if I can dispatch that 10 kilowatt. And today, there is no mechanism by which you can take that 10 kilowatt in the market. There are aggregators who are doing it, but it is very, very difficult in the current setup. So that need to change. As far as the market model, market models are like, the ISO market, if you look at in US, I call it antique because they are designed to support central generators. They are designed to support gas turbine. If you look at New England ISO, they have reserve margin requirement for 10 minutes and 30 minutes. Now, if you put a battery doesn't work that way. It can work 10 minutes, 30 minutes, once battery is there, it's on. So, but New England ISO has hard time recognizing battery as a solution. There is a big debate going on and very reluctantly they agreed. So there is a need for changing the market design which can value these resources in a right manner. Because if you don't provide the market for the resources, then obviously they are going to go to the politicians and policymaker and regulators saying that you make a policy that I get a return on my investment. So I think there is a debate and is required that you have to change current market model, which is like more susceptible, more able to recognize distributed energy resources. The third thing is the business model. So here there are a couple of things actually. One, I don't know in this audience if people who are entrepreneurs or the companies, one thing you need to understand is that utility business is not of a Silicon Valley startup business. What I mean by that is you don't expect that in 3 to 5 years you will be able to break even and make money. Whatever I have seen so far in US, the successful startups are at least 10 years old. So what it means is that this is a long-term play in the market. So if you create your business model, if you want to get into the business of doing this distributed energy resources kind of business in the long term, you have to essentially prepare for a long-term vision. The other thing in the business model comes is that when we talk about long-term business kind of model for the industry, I think the politicians and the policymakers and regulators need to understand that they also need to give a certainty in their policies, because if somebody is going to start this business, they need at least 10 years where they will be able to break even. And if you change the rules of the game in between, it can seriously jeopardize their business. So that is very important from a business point of view. Then right tariff structures, a lot of debate actually right now on how to price for the services provided by DERs, how to price the value of products, and that's really very carefully has to be looked into, like critical peak pricing and so many avoided cost methods, and so many things are debated right now. Like there is a paper out in New York, they are trying to figure out how to value these things, and that's in the right direction. But essentially, you need to come up with that business model, like how you are going to charge your customers, what kind of services. So if utilities are going to lose their revenues from providing electricity, and they are looking for an alternative, how they are going to charge to their customer, how they are going to make money, that has to be debated. So that's the debate like on the business model. So what should be the business model? And there is a paper out actually in California recently, and they proposed like 4 different models of the business. One is you can expand the monopoly of the utility, which is like right now, most of the utilities are. The second model calls for an independent distribution service provider. Essentially, the idea is that the operation of the platform, you can separate from the utility core functions so that utilities also can participate, and like technology companies also can participate and provide DER service to the market. The third is utility as a facilitator of distribution services. So essentially utility become a DSP, but then either they are restricted from doing many other things, and then utilities are like, kind of wires company. So I don't want to kind of get into the detail, but there are pros and cons of each model. But essentially what happens that as you move from your traditional model, which is cost of service and getting a fixed return, there are new opportunities get created for utilities to play. So what I would say that there are these, you should follow these debates closely. You should debate internally. What I can only say is that there are possibilities of earning more revenue, but you may have to do a little bit more work as a utility. So be prepared for that, but as you can see here, you can get a lot of money generated through transaction services charges. You can, get to supply some products which nobody else is supplying in the market. So there are various kind of, options available for utilities to play depending on what they want to become in like 5 to 10 years. So that is to be debated, and that's what is going on in US right now. I think the fourth thing is the technology model. So, we all know that utilities spend huge amount of money in buying softwares and technologies and all, but at the end, they all fail to integrate. So interoperability of the technology is a big challenge. And I'm seeing that in case of this distributed energy resources also, when I'm working with my clients, they all recognize that there is a value, but how to get that value? The technology part, the creating the platform, creating the standard, creating the right technology is a very big challenge. So there are a lot of debate going on in that, and that's something which is, but the whole thing is that whatever way you go, you should ensure that there is an interoperability of the technologies ensured. So you should come up with a standard that, wide range of technologies can work. Don't get bogged down with one provider. It's always that, I start working with this guy, but at the end you will find after 2-3 years that you now cannot move from that to others because he has choked you. So be smart, try to be more standard based, and look at what's coming in the market. So this is like a model, if you're trying to combine everything, what essentially I did actually is that I put together for my clients a framework which compel them to think through all the aspects of developing their capability toward the distributed energy resources. So as we just said, it's not about technology, it's just not about business, it's not about operation, it's also about market. And for each aspects, you need certain amount of capabilities, and you have to develop those capabilities over a period of time. And I should tell you this thing, that this is not a short-term game, it's a long-term play. So you are talking about what is your future as a utility. So you're talking about 3 to 5 years down the line what will happen. So, but you have to have a very systematic approach. You should understand all the gaps which exist today and then kind of work on that. And so this capability model has 3 dimensions. The institutional part, which is very important, like technology, people, processes, kind of creating the operations and market rules. But then there is 2 more dimensions, like what products you will be offering. So it's not that you can offer all the products from day one, because each product has certain subtle kind of requirements with them. So you may have demand response initially, you may add up energy efficiency, you can add up storage, but that is the product dimensions. You need capabilities with each of those things as you add. And then there is a service dimension. As you kind of add more and more capabilities, you need to be thinking about what kind of services we can provide, and you can go from there. So how to adopt for your needs? And I have kind of thought of this, and this is like a long laundry list, but I think for each of you, like if you are a generator, if you are a market operator, if you are a transmission provider, whosoever you are, there are some things you need to think. For example, a generator need to be ready for competing with load. So load is going to become a new generator in the market, and you should get ready to compete with load as a generator. So you should not think that, okay, you know, Colombia is going to grow by this percentage in next 10 years, so I have to build this much capacity. You should understand that in that period, a lot of load also will come in the market which will compete with the generation. So you may not need that much generation. You know, market operators, they need to critically examine the, you know, the current products in the market, what is there, what is not there, and you know, what they need. Customers advocate, like, you know, you have to increase awareness among the customers. Customers are not like, you know, bought into this even in US right now. So that is one thing which need to be done. Like transmission providers, the two things, you know, in your planning, you need to understand that now the planning is moving from how to avoid building a transmission line. So this is the real thing, you know, you may not be able to recover your cost if you keep building your transmission lines and hope for it. And, sorry, I jumped. And I think for regulators also, they need to have courage to kind of enact these bold visions and, you know, take care of long-term view in the market. So essentially, this is a cycle. You need to understand your unique challenges. You need to, you know, don't discard the global trends. Sometimes people think that, oh, this is Colombia and, you know, it doesn't matter to me. But no, the technology disruption is so fast that it will just overrun you if you don't prepare to change. Identify your risk and exposure, and don't undertake incremental ad hoc approaches that will backfire. So that's what I wanted to say, and I hope this was useful, and I'm available here like today and tomorrow if you want to talk to me for anything what I presented. Thank you very much.